bit back, but we are just defining the main concepts here, version control and also version control systems, and explaining some kind of situation that we commonly face, like having the same project we are working in different copies, just to keep track of the progress we are doing. And in case we had to go back, we usually try to have a backup of these different copies. But the problem is we end up having a lot of files with the same, mainly the same content inside. And for this, in the past, started to appear these version control system tools. The first tools were just for keeping track of the progress of the files. So it was like having a constructive history of the file without having the same information duplicated in the computer or whatever we are working. But another problem that arises when we start working with, for example, teams or group in collaboration, I think that many of you might be familiar with this kind of error where we have conflicts working on different copies of a file or a project. So quickly, version control system started to solve this kind of problem. And the first version, we are implementing what they call file locking. And they allow only one person at a time to work on a specific file. This solved the issue of having conflicts when merging the files or data set, whatever we are working in a team in collaboration. But as you might imagine, the efficiency on working in this kind of system wasn't good at all, because only one person can work at a time on one resource. And another common problem that I have here in this cartoon is that this system were ensuring that no one else was working on the file we are editing. But when we place back the file to the folder, the repository where we are working, we are not sure that someone else is going to edit another resource that we depend on, or in a different way, that our new version is going to work with the file that other people are editing. So solving all these common problems when working in collaboration, mainly in software, but also in other kind of data. Several tools appear in the past, but nowadays Git is one of the most used. And I will just highlight 3 features here of Git that is a distributed version control that allows us to efficiently track these changes and also manage multiple versions of a project in parallel. So highlighting here, we are going to have a track of all the changes that we are doing on our files. We have the ability of branching and merging. This means that we can work on different copies of the project and have different work in progress versions. And then after we test and we are making some progress on this, we can merge back this progress. And also it includes several tools for resolving any conflict when we are going to merge these files after editing. So getting this a bit down, I have some simple diagrams here to explain this. When we talk about our folder or working directory, that the formal definition is a repository where we have all the files associated with our project. We have different branches, as I mentioned, where we can include different features and try different things. But commonly we have a master branch where we publish all the more stable version of our project and the material that we have there that it is ready to use by someone else. I don't like talking only about software because many people is using this kind of tools for also managing data sets and other kind of things. In this diagram, you can see different round markers. These are called commits. Each commit is a mark on the time where we release not a stable version or a finished product, but it can be just the work that we have done on this week. And we want to compile the progress that we have in our project. And we associate with a description of that version that can still be under development. So what we end having is like a tree of different branches with different branches, and all of them are going to be then merged into a master branch. But some of them might end up in nothing if we are just trying a new feature and we don't decide to include in our final master branch. It's probably that we can that branch is not going to be merged into the main branch. Here also we can see that while we are working on a different branch, including some new features, for example, in a code, in a script, or even a library, someone else can take that last release and work in another feature, include some different functions or whatever, and then all these new features can be included in a final version released in the master channel. Here I would like to show just how it is commonly used and mainly in the past was used using different commands for those that are familiar to the console, the terminal, or command line tools. Today I don't want to use this because maybe to make more accessible for all the levels in terms of coding and using this kind of tool. I choose to show these examples today using GitHub Desktop. And here I would like to clarify the difference between Git and GitHub. Git was this initial command line tool that was implemented for doing all those tracking of the changes and also managing the different versions. And GitHub is a cloud service where we can host our code and work using all the features that we can take advantage using Git. So GitHub is a code hosting platform for version control and collaboration. It lets us and others work together on projects from anywhere. I don't know here how many of you could install GitHub Desktop. If you have any problem installing it, we are all okay? Okay, perfect. This is a screenshot, a small video of GitHub Desktop, where we are going to look at the example today. And instead of showing many slides with what we can do, I think that a better idea would be to try to do something together, real time, in collaboration. And for this, I thought about doing an agronomic calculator using Python, where all of us can think about a really simple function that is for your interest in your research, or even for any agronomist or researcher in agronomy. And for those that are not familiar in Python, I would like to also have the opportunity on collaborating on this live demonstration. For this, I would like to share just a small examples on how we can create a function using Python. Here I have a function that might be of interest for most of us on how we can convert acres to hectares. We start defining the name of the function with def space, the name of the function without including any space or any special characters. And between parentheses, we place the parameter of the function. In this case, it's going to be acres, the number of acres that we are providing. And we finish the definition of the function with some columns at the end. Then in the following line here, there is a description. So if someone else is going to work on this code or is going to use this function, can have a better understanding of what we are doing in the function. And for this, we just write the description between 3 quotation marks after defining the name of the function. An important thing we have to respect is leaving here 4 spaces when we are writing a function in Python. And after that, we can work the body of the function. In this case, we are just having a one-line function that is returning, specified with the instruction return, the number that we provided of acres multiplied by a conversion factor, returning the number of hectares as a result of the function. I will show the same function because we can have different flavors of how we can program this kind of simple function. And there is no perfect way to do it. Again, the name of the function, def space, the name without any special character, and 1 parameter, in this case, the number of acres. We can also include a more descriptive string here for example, a description on the parameters or arguments and what value we are returning from the function. And the body in this case has more than 1 line. We are storing the conversion factor as a variable. placing the name of the variable that we can choose whatever name we want, equals, and the number that we are going to save there. In the following line, we can see that is computing the number of hectares and storing in a variable hectares. And the last line here is returning the value of hectares as a result of the function. For those that want to explore maybe a more creative way, we can also include different parameters. I have here an example of a function using 2 parameters. It's defined pretty similar than the previous example, but we separate the parameters with a comma. We can include as many as you want. Then the description again between the 3 quotation marks. And in this case, we are computing volumetric water content of soil moisture by providing gravimetric water content and the bulk density of the soil. So summarizing how we can create a function in Python, if you want to take a picture for using in the lab example, feel free to do it. We have here the 3 examples. And now I would like to just go to GitHub and start creating a repository where I hope that all together we can collaborate and create an example of an agronomic calculator together. So for this, I will start logging in. I'm happy that we have the president here of the HS. Awesome. Let's start installing the software. So for using Python, I will install Anaconda here in the small guide that was in the flyer. You can download Anaconda and also GitHub desktop. Perfect. It's going to ask for signing into your GitHub username. Authorize. Start a name, an email, and we are ready to use GitHub desktop. Also, let's see. Yeah.
Okay. I'm not sure we should see something in the screen, but we're not seeing what we're doing.
Oh. Sorry. Thank you, Carlos.
That's okay.
Okay. So I will proceed to install Anaconda. Thanks. In the meantime, I will start creating the repository where we are going to place our code. And for that, we can just go to github.com. You don't have to do it now, so we work all together in the same repository. But if you want to follow or check later for creating your own repository. We are going to leave this code as public so anyone can make a copy, work on this code. And here we are going to include a git ignore file that is going to tell Git which file we should ignore. In this case, we use just a template for Python, and we will recognize which file is important to include and which one to ignore. We create the repository, and now we have a place where we can place our code, in this case, and share with anyone, and receive also collaborations and other features that we are going to see. The first step is to, I think that here you can just follow on the screen, and then we go to our own computers. So I will show how you can clone a repository from a GitHub website. In this case, as we have installed open GitHub Desktop, we just click on Open. And this is going to open GitHub Desktop. And we can specify a path where we want to store this project. In this case, it's going to be in Documents folder, GitHub, and the name of the repository. So after we clone the repository, we can start working on creating files. For this, I would like Anaconda to finish the installation. Or we can show the folder using the file explorer of your computer. We can start, for example, creating the Python file here. Let's say calculator.py. That is the file type Python. Define approach. So we need to change this, the extension from txt to py. Yes. And now we have the file where we are going to work. So if we go back to GitHub Desktop, we can see here the creation of the file that was detected inside the repository. And we have an option to commit this event to the repository. In this case, we're working, let me hide this, on the main branch. And it's suggesting a description, a title for this commit, create calculator.py. We can just expand this description here. The main file, project, we click commit, push this file into the repository. And if we go back to the website of GitHub that is hosting our repository and refresh, we should see here the file that we just created. So now, I think we should have an Anaconda here. I will open Anaconda. And for editing this Python code, today we'll use JupyterLab. So if you want to open in your Anaconda, in your computer, JupyterLab, it should open a browser where you may see the working place of JupyterLab. So once we have Jupyter Lab in our browser, we can look at the left into the different folders and navigate to the place where we cloned our repository. And here we can see our file calculator.py. So to have some content inside the file, I will just start creating the function that we had in the example. Description. Acres times the conversion factor. And with this, we have our first function. But before you can see the changes here, we have the addition of these 3 new lines on the code. But before committing the changes into our repository, we should make sure that the function is working properly. So before committing, we can do a bit of testing. For this is useful a notebook where we can import our calculator. And here, pressing tab after writing calculator and a dot, we should see the name of the function. So let's try with 1 acre, 0.4 hectares. So the function is working. And once we have a feature that it's ready to include in our code, we proceed to do the commit. In this case, we don't have any hint here because GitHub doesn't know what we have done. But we can place creation, the acres to hectare function. And we commit this function.
What was the reason why you were ignoring the py file?
Sorry, Nico, which py file? Oh, you are asking about the git ignore file? Yeah, and that file, for example, if we go here to the repository folder, we have this folder called pycache. This is not relevant to our code. It's just our code compile, and it includes instruction for the computer that we cannot even understand if we read. So when you specify a git ignore, depending on the platform where you are working, GitHub is going to know which file is not relevant and has a compiled code or any temporary file, and it's not going to include that in the main repository. So now going back to the website, we have our new file. I mean, it's the same file with the changes that we are doing over the initial version. And here, if you want to include and collaborate in this real-time example, I would encourage to go to the site and do a fork of this repository. Doing a fork is similar to creating a new branch, but you're having a fresh copy of the last version in your own profile. So if the owner of the repository deletes the initial version or whatever happens to the repository, you are going to still have your own copy in your profile. So when you go here, it's going to ask for a repository name. You can keep the same one if you want, because it's going to be associated also with your user. A description, and you're going to copy the main branch into your new fork. after that, you just click on create fork. And again, to work on your fresh copy of the repository, you can go to code and open the forked version with GitHub Desktop. Don't know if anyone is having any issue forking the repository into your user and then cloning this version into your computer.
It's not appear in the repository on HSA account.
Or maybe there is a confusion because AGSA has a user that is AGSA dash agronomy. And there is also, if you are there, AGSA dash KSU is the organization where we are actually putting all the examples of the workshops after we finish there to compile everything. So yeah, the URL is github.com/agsa-agronomic/agronomic_calculator exam. So here we start seeing that the number of forks of the repository. There is also a nice feature here. If we go to Insights, Network, we can see the whole history. Once the other forks start having some progress, it's going to display here the different versions and what the people is doing with the source code that we have here. So once you clone your own fork using GitHub Desktop, you can go, sorry, yep. Oh, yeah. Okay, so the URL is also on the chat on Zoom. So once you clone your repository, you can start by going into the directory where it's cloned. And if you have Jupyter Lab installed, you can go using the browser to the file calculator.py. And here start writing your own function. It could be anything, conversion of units or whatever simple operation that you feel comfortable adding here. If you have any error, don't worry, because as the good thing on this platform is that it's a collaboration tool, so you can include code, and that's something that usually happens. Include code that is not perfect, and someone else is going to take this version and improve it or correcting any possible mistake. So once you add a second function here, let's do again in the example. And choose the same example, volumetric water content. So volumetric water content. And we take as a parameter the gravimetric water content and the bulk density of the soil. So convert water content thing. Density soil. Let's be a nice example for having more than one line. Here, we can return gravimetric water content times the volume density. And after uploading anything into GitHub, we can test it by going into the notebook. And an important step here is that if we haven't done any change in the calculator module, we have to restart the kernel of Jupyter Lab and run import again. So we have our updated version. Here we can see that we have the new function by placing the name without parentheses and a question mark. We get a description of the function. So we can see the doc string stating that the function is for converting gravimetric water content into volumetric water content. And we can just test the function. Say it's 0.25. Now volume density 1.20. Function is working properly. And with this, we can go here and update the code. So we don't have any need to keep updating this notebook. So I'll just uncheck here. And this commit will only include the new function that we just created. Commit to main and push once we created the commit. So here, if we go back to the repository on the browser, let's check the network. And we still have our own fork. I know if someone is trying to add a function here and push a commit. Different forks. Sorry. See if we have some progress. Gonna look it. I try to. Example. So we start here seeing some progress. As we have the example from Nicolas. No, it's perfect. And we can see here when we have different collaboration from different people, what they are doing with our code or the code that we are also collaborating. We can go to the commit and have some insights on the progress that was, or the changes that were made. We can see the description is a function for converting pounds into kilograms. And we have the new function here that he just created. So how we can include this into the main branch once we have a cool features that we created or someone else created in our code? We go to the main repository and we can create what is called a pull request. That is the act of including someone else's progress into our code. For this, we can create a new pull request. And here, we only see our own branches. In this case, the AGSA agronomy user has only a main branch. But if we go here, we can compare across different forks. This includes a version from other people. And we are going to include into the base repository of AGSA agronomy the changes that were done by Nico in the same repository. So we can have a preview of the changes that are going to be included. And we can create the pull request. In this case, we have a warning here that we cannot automatically merge. This is equivalent to having a conflict using any cloud service like OneDrive or Dropbox. but we still can create or we can try to include this code into our main repository. Update main. We can here have a greater description what we are including into this new version. And we create the pull request that HSA Agronomy wants to merge one commit from Nicolas' repository. But we are getting this warning that the branch has some conflict that must be resolved before doing the merge. So here we'll open using GitHub Desktop the conflicts. So you see, look at them, and let's see what can we do to solve it. Okay. Let's go into here. Oh, you created a new pull request? Ah, okay. So we have an issue here. It's not clear where we have a problem. So it's suggesting using the command line, but we should have a workaround without using it. So we can still keep this easy. Check the file. Maybe something with the writing privilege. Yeah, you want to check if you can approve the pull request in the website, because it's strange that we should get where we have a conflict in GitHub, we should get inside the file some description where we have any conflict. In the meantime, we can go to the other one that is without any conflict, and let's merge this into the main branch. So now we have a function for converting corn bushel to kilograms per hectare. Start looking at the different progress. We have the same function. Yeah, but we have two forks with the same function. Yeah, but we can include both of them. We don't have any problem here. That's funny. So we can start a new pull request. It's still giving that difference there. Shouldn't be too complex to solve on the web. Okay. And here we can see the conflict on the file without using the command line. It took a bit, but it is possible to do it. So the problem here was that while I was adding the second function into the main repository, in this example, Nicholas was working on the function for converting pound into kilograms. So going back to the slide, we have this kind of situation where we started working on different features and with different initial versions, and now we have to solve the file to merge them both at the same time. Here we see that the first feature was merged in the next commit, and the second feature was merged later. But here we are working with features with different initial versions, but merged at the same time in the same commit. So it is stating that we have a conflict and suggesting using a notepad for editing. And in this case, both changes are perfect because one is including the second example in the main branch, and the other one is just creating a new function. So we don't have to change nothing here. But sometimes, for example, we have a dependency on another function, and we have to just check that everything here between the markers of the conflict is making sense.
So those arrowheads are gonna tell me where that conflict is.
Yeah. And if you, for example, change the version of a library when you're working with different packages or libraries, you might have different version names from someone else's version of your own project. And you're going to have multiple blocks where you have any difference. I mean, it's the same line, but maybe they changed the function name in a new library and you are using an old one. So we're going to have multiple chunks of conflicts that you just edit them, and you usually keep with the best one. But in this case, both blocks are correct because we are not working on the same function. But imagine that, for example, this conflict was something like this. In this case, example, we have the same content in both versions. They are both correct, but for example, here could be using an older library, and you will have differences in the same code. So it's going to state that you have a conflict. And you have to go by hand and change that until the code is working perfect, and you can safely remove these markers. I will leave both functions and remove the markers. Now that we are sure it's working, we can go back to the browser and test out the function. We have the three functions. the one that we have in the main branch and the one that Nicholas created here. And we can run and check that everything working fine. So now GitHub has detected that there is no more conflict on the versions, and we can proceed to merge the changes into the main repository. After we commit the merge, we have to push the merge into the main branch. And we have again some errors. But it's about permission, so we can check here. Still have conflicts. Nice. I think that maybe you should write the changes, because I am working on your fork. You can go to. Yeah. Here we have new changes last time. And now we are able to do the pull request. So here, I want to go back a bit. The problem was that we had a conflict on the fork, and we were editing with another account different than the owner of the fork. Now that the owner of the fork did the according changes to be compatible with the last version, we can confirm the merge. And we have finally included the first pull request into the main branch. Going here to the network, we're going to start seeing how the things are looking. We have still the pull request from Ignacio, Masigoche, and Gustavo. We have to create a pull request to include the function. We have still this one that I will go there so we can. Here was a new version that you updated from new version, but it was in the last version that we didn't use. So it's important thing on keeping updated with that version, but I mean it's a problem that is arising here because we are going to have working in a real time. But usually you have a change like this in days or weeks. And then for security, the advantage is and then how do you speak about your working on your example? In that case, I wanted to create some content for different branches and different commits, so we can see now how we can go back and remove something that we don't like, create our own version of the library in a mix of different commits from different people. So how to open page? So now here, for those following the screen or via Zoom, you may see that we were working on the changes and the website was refreshing, checking the compatibility while we were doing the required changes in the code. And finally, we got a compatible version that we can merge into the main branch. And it's going to include a function for converting corn grain yield in bushel per acres to kilograms per hectare.
So sometimes, I mean, this just they are calling it like the main branch, but sometimes I read that it's also like the master branch.
Yeah.
What is
the name? I mean, usually you have to specify here in the settings of the repository. If you go to branches, maybe in general, you have here in general the default branch. This is the branch that the people is going to get when they just clone your repository. Some people like to have, for example, a development branch as a default, where they work on new features and the main branch is a bit behind with the last stable release. But that is just as you prefer. The important thing is that every time you want to include something that you're not sure if it's going to work, if you're going to finish, for example, today, or even if it's going to include it in the final version, you create a new branch and you work on that branch. So going back to Ignacio's question, in this example that we are doing live here, we are using different forks and different people working on this. But if you're going to work on our own, we are on the main branch. Let's say that we are going to include a function that we are not sure if it's going to be possible to call it just using Python without any library. So we go to branch, new branch. We create a name. Let's call it unsure feature, because we are not sure of including it. Let's go back to the code, do some changes. So let's say create plot. Yield. And yield is also a word that we have to take care when using Python, because it's used by the system, that word. And let's call a function from a plotting library of Python that we do not have here. So we add a function that we are not sure if it's going to work. And we can, without testing let's say that we are going to work tomorrow. We know that it's not going to work, this function, because it's not finished yet. But we can still place a commit, work in progress, dotting feature. We commit this progress into the ensure feature. And we have a point where we can keep working tomorrow or another moment. If we need to go back to our last working version, we just click here and go back to main. And the code is going to include the last stable version that we have on the main channel. So that's it. The cool thing when you are working on your own and you want to try a different library, a different approach, even for analyzing your data, you start create a branch and you place these new ideas, see if they are going to work. If you're happy with the result, you then create a pull request similar to the one we did before, but only using your own username, but different branches. And you include this new feature that you are just trying into the main channel after checking that it is better than the previous version. No, for that, you just need to be constantly, I mean, you need to do like every hour or every minute. But whenever you feel that you have some content that you can measure in the times and progress, you just do the commit, and that is going to save that backup for you if you want to go back later. So let's say you want to go to the initial commit, and you can create a branch from this commit, and you're going to have the version of that commit in a fresh copy when you're on the same repository but a different branch. So I will. Every time you are making a commit, it's like pressing save. You're going to say a message, a description of what is inside that commit, and it's going to be available in the time if you want to go back, and also if someone else want to include it in their own copy of the work. Yeah, if you start running a fresh focus and the file here. Let's go back to the network, the repository. And the last version here. So once we have a progress in the timeline of the project, as we saw earlier, we can create a branch from different commits that we have here. We can start creating from the plain calculator that was without any function inside. We create a branch from here. Let's call it Scratch version. And here we did when the file was empty, but you can do this at any point of the different version you have in your repository. And you can start dragging from here the features that you want to include in your file. For example, let's say that we're interested in having this feature in the new branch. We can drag the commit. This is called cherry picking because you are actually taking just the feature you are interested in including and drag to your branch.
But they're only doing the lines that were added, right?
Yes, you are only moving that changes, even if there are some lines that were removed. You are then not going to have those changes in your version. Yes, yes, because it's not going to create the file. That's why I choose the commit after creating the file. Just a change. Exactly. Let's say here creation. And we have the pull request here to preview. Oh, yeah, copy. So the two functions here. Create a new function. It's divided by volume. Result. Description improved. So here, if we go to the history, we can see the two commits. Let's say that we are only interested in including this one into the Scratch version.
So there's like a feature here when you create a new branch that they ask for a remote name.
Let me check
They're
here.
trying to open a new branch from R. Yes. But he asks for the remote name. I was wondering how.
Branch. Shut the name of the new branch. No, it's going to be inside the
remote name might be the name of the branch. Branch. This is the name of. I saw it. That point is inside this branch.
That is when you start working with only branches that, for example, you can your computer cannot publish on GitHub. Like a code different story. Because you cannot do anything on GitHub into the local branch. That's right, the branch is covering it. So here when doing the cherry picking, we have some conflicts. So I will just check them. In this case, it's just checking that everything is looking good. Save it. And we'll do the cherry picking into our version. No, someone else has any question? That's a good question. When you have here the changes ready for submitting, you will have many files. We can try just. We have. So here, when you have the two files created, you can see the changes and check that is what you want to upload. And you can check here what to include in the commit and what to ignore. For example, when we created the notebook for testing the Python module that we were creating, I mean, it was senseless to upload that notebook to the repository. So we just remove it from here. And the same when you have the conflicts, you're going to have those conflict marks inside the file, inside each of the files. So GitHub is going to state how to fix this and this and this file, and you go through them looking for conflicts. Yeah. I mean, you are always working in the same folder. So if you create a file, it's going to, inside the folder, it's going to appear here without taking into account which branch you are working. But you can choose which files to include, even creations, changes, or if you are going to delete any file, you can choose to include that in the commit or not. So you still have the same problems that you have, for example, if you are going to share in OneDrive your files for collaboration, you have the same conflicts because, I mean, it happens that you are working on different versions with different people at the same time, but it helps you in to where to look for these conflicts and how to solve the conflicts. And also it's way better in terms of going back and looking what we have modified in the file.
Well, I have a repository that I uploaded. I didn't realize, and I uploaded to. I tried to, but I put at the end some images that were very late.
Yes.
And then I updated my git ignore for not sending those images, but it seems like it's still trying to load up those.
Or after they were maybe you change that after you did the commit, maybe. Yeah. So if you start, so that's why it's important to start the git ignore before having any file that you want to ignore. Because after you introduce them to GitHub, I mean, you have to go and remove a hand. Git ignore is not going to remove anything from your repository. But yes, it's going to prevent new files like the one you specify there to be uploaded. Sometimes when you have them here, let's create again these files. What you can do is from here, add the file to git ignore before doing the commit. Just right click on the file, on the name of the file, and click add to git ignore. And the file disappears from here, but you have the change inside the git ignore to ready to commit. And to keep this feature working in the future, you have to commit the new git ignore. We have the new pull request here. And it's ready to merge. We shouldn't merge. Okay. So another thing that you can do when you want to discard any pull request is just close it without doing the merge. I'm not going to do it now, but if you have something you want to discard, just close the pull request. Yeah, I think we are on time.
So, say like, if I do not know anything, what does pool mean? Like,
okay.
Something.
Initially, when you talk about pool, is taking the last content from the repository. But when you are doing the pull request, you are requesting the main branch to pull the changes from your own branch. It's like not the same concept, exactly the same concept. I like suggesting pulling the data from my folder because you can change this version or a new feature that you should include. So you request them to pull the data from your repository.
So you know, like you made some changes and you are requesting to
Yes, yes. It's like a great way, especially for organizations where they don't know, or even open source project, where they don't know if you are good programming or not, or if your feature, I mean, they are not looking for all the copies of the software that are out there. So you suggest including your version, and they eventually might accept the pull request and do the changes. They might request changes without, especially using the web version. You have really nice features on commenting line by line. Let's improve this one, change this. And you accept the same part. It's a good question. I think you can change the number of comments inside the pull request. You can say let's exclude this comment there, just include it. Then, yeah. Let's say that I create a form. Yeah. And we were seeing there in the graph that, for example, our online forms, see there. You can see what we are doing in our files now. No, I mean the progress that is displayed here is only the no. Whenever you do a commit, you are going to display that on the graph. Yeah. So if you just download it and work it. No, but I mean the moment that define that your changes are going to appear here is when you do the commit and you push into GitHub and you're working on a fork. Yeah, so here you have, it's looking great. I think it's really big for the amount of time that we spend working on different copies. I imagine a library or some project with a lot of files and a lot of people working there. It gives you really nice features for controlling. Even there are more advanced features, like for example, actions, where you can automate the testing of your project. For example, here we are working in Python, we can implement a workflow that tests that the library compiles without any error and all the functions are working. And every time that you do a pull request, it's going to run testing and it's going to pre-approve or pre-discard the pull request. Yeah, file by file testing, exactly. That's the main function. You can have some assumptions in terms of values that you have to receive when running some function or some output you are expecting. And you just check that you receive that output and not an error in the middle. Then you can, I mean, there are lots of features over GitHub that are complementing Git. For example, I don't know if you have looked at different repositories of libraries, you will see the issues tab here sometimes. I think if we go to the main, we should see. I hear people that don't have any experience or don't feel comfortable editing the code, but they can still submit any bug or point any error in the code using these issues. And then the team in charge of the library or the project can go and address that, mark them as solved. Even you can link the issues with the pull request and the versions that you are releasing. So yeah, you have a really nice control on terms of tracking software, but there are people, as I said, using this for different things, like for example, having data set CSV files with different versions and changes inside. And well, another feature that sometimes is useful is using GitHub web page, where you can include a small website inside the repository. For example, this workshop was inside the AGSA organization. And here is a branch with the web page. So you can create a documentation, for example, explaining all the functions, what you can do with your library. Let me check if I can access. Here we have the configuration. We specify a branch and a folder where we are creating the files for the website. And it's looking for just a markdown file, or it could be a HTML if you want to make something maybe cooler. But if you want something simple just with markdown, you can create a website like this one. And everything is going to be kept together with the repository. I don't know if we have any other question. Yeah, we can do an example in the calculator repository. So the first step is to go to the repository. And inside settings, there is a tab for pages. We specify to deploy the website from a specific branch. We should create a new one just to have everything in place. Just branch. It's called the branch web page. Yeah. Maybe we are going to short a bit the video, but we are going to upload everything. So going to pages, deploy from a branch. Now we should see the web page branch. We can specify to use the markdown in the root of the directory, or we can go, for example, for a docs folder in case we want to keep another content in the root. And this is going to create an action here. Let's try it. Going to the web page branch. We create the docs folder where to take the, sorry. We have to use default names. They could be like index.html, readme.md. You can check the documentation. Just we can write, for example, info. Space a small description there. And we can commit this. And now it's building the website using that actions. When we went to settings and specify all the description for creating the website, GitHub automatically created a workflow for compiling the website and deploying every time we do a push on the web page branch. This should take some minutes. And it's going to return here the URL where we can access the repository website. Even there are some scripts that will pull, for example, all the functions inside our folders and create the entire documentation for our code by just looking at the function name and the description under the function. So that's a nice feature in case you want to automate the whole documentation creation. And here we can see the.
Can you create a web page like HTML5? Can you put it there or?
Just in Markdown. GitHub is converting Markdown into a HTML version for the browser. You can use, if you want, you can use your own HTML here instead of including the Markdown. And in that case, GitHub is only going to copy the file into the website. But the good thing is you don't have to worry about domains, servers, where to host the website. Just include here a Markdown or whatever, and you get a nice website for the repository for the project.
The website will be showing only what is on the Markdown.
Yes, yes. There are even some themes that you can apply for visualization into the file, into the website. But if you want to go to something more customizable, yeah, going for HTML will be better. But I mean, it's something fast, and you can include images, nice description, code chunks, and having everything there in place.